All right, let's dive into a really critical piece of the Cisco SD access puzzle, the Fusion router. We're going to break down exactly what this thing is, why you absolutely need it, and how you can use it to connect your secure campus fabric to, well, everything else. So, at its heart, right, Cisco SD Access is all about making the campus network easier to manage and way more secure. And how does it do that? Well, it creates these isolated virtual networks using a tech called virtual routing and forwarding, or VRFs. You can literally think of them like self-contained universes, one for your engineering team, one for finance. You get the idea. And this is awesome for security and segmentation. Okay, but here's the catch. This isolation, as great as it is, brings up a big problem. I mean, you've got all these separate virtual networks, right? But they all need to talk to shared stuff. Common resources like DNS to find things on the network, DHCP to get an IP address, or maybe your identity services engine. So the big question is, how do you let them access those services without completely destroying the security and segmentation you just built? How do you avoid punching a giant hole in your defenses? Well, that's where this thing called a Fusion router comes in. It's the solution. Think of it as the purpose-built, super-controlled bridge that connects your automated fabric to all those external services. Now, here's something that might surprise you. The Fusion router. It's not managed by Cisco DNA Center like everything else in the fabric, and that's totally on purpose. It's meant to be configured manually. Why? Because it gives you, the network engineer, that precise, hands-on control to say exactly what traffic can and can't move between these different network worlds. So how does it actually do this? What's the secret sauce? Well, the magic behind the Fusion router is a technique called VRF route leaking. And this isn't just your standard, everyday routing. No, it's way more sophisticated. It's all about a controlled process of selectively sharing or, leaking very specific routes from one isolated network into another. This is how you can build these super specific, policy-driven pathways for communication between networks that are otherwise completely separate. Okay, so how does this look in the real world? When you actually go to deploy one, there are basically two main ways to do it. And it really just comes down to where your shared services are located in your network. All right, let's start with scenario number one. This is by far the most common setup. It's where all your shared services, your DNS, your DHCP servers, they just live in the network's main routing table, the global routing table. This is the default on pretty much any network device you'll touch. And this diagram really shows you what's happening. See, the Fabric border node, it sets up a BGP session with the Fusion router for each of your user networks. Then the Fusion router connects out to those shared services sitting in the global routing table. The real magic is in the config on that router. It's using policies like route maps to be super careful about which routes get leaked from that global table into the user networks, and also which user routes are allowed to go back out. Total control. Okay, but what if you're a bit more security focused? What if your shared services are also segmented? What if they live in their own isolated VRF? This is a pretty common design, especially in environments where security is priority number one. Well, in that case, the Fusion router's job changes a little. Now it has to leak routes between multiple VRFs, not just to the global table. So your config will have separate VRFs for your users and for your shared services. The way we control this is with BGP route targets. The best way to think about these is like price tags. You tag a route when you send it out of one VRF, and then another VRF can be told to only import routes that have a specific tag. It gives you this incredibly fine-grained control over exactly which VRFs can talk to each other. All right, up to now, we've just been talking about routers, but the role of the Fusion device doesn't have to stop at just routing. And honestly, this is where things get really, really cool. You can take your security to a whole new level by using a next-gen firewall to do this job. It's as simple as this. You swap out that router for a firewall. Just like that, you've turned a simple connection point into a powerful security checkpoint. Now, all of that traffic that needs to be leaked between your networks, it has to pass right through the firewall. And that means it can be inspected, controlled, and secured. And doing that immediately unlocks a ton of new security features. We're talking stateful inspection, so the firewall knows the full context of a conversation. We're talking application visibility and control, so you can see exactly what apps people are using. You can even write policies based on scalable group tags, or SGTs, which gets you into true identity-based security. And of course, you get that deep, detailed, firewall-grade logging for absolutely everything. But hey, if you really want to go all out, if you want the maximum level of security possible, you can use a device like Cisco's Firepower Threat Defense, or FTD, as your fusion device. And when you do that, you unlock a whole new world of advanced threat protection. With FTG in that spot, you're not just routing and filtering traffic anymore. You are actively defending your network. You get a next-gen intrusion prevention system, NGIPS, that can spot and stop complex attacks cold. You get advanced malware protection, AMP, to find and block malicious files before they can do any damage. You can even decrypt encrypted TLS traffic to find threats that are trying to hide. Plus, you get powerful URL filtering. It is, without a doubt, a massive security upgrade. Okay, so let's wrap this up and pull together the most important things to remember from all this. So here's the bottom line. The Fusion router is that critical, manually configured bridge between your automated SD access fabric and your shared services. Yes, it provides the basic connectivity your network needs to work. But way more importantly, it gives you a strategic choke point where you can inspect traffic and enforce your most important security policies. It's the gatekeeper. Look, understanding this role is absolutely essential if you want to design a really solid and secure SD access network. So now you can start thinking about your own architecture and ask yourself a really important question. Is that connection point in your network just a simple path for traffic, or is it your most powerful line of defense?